Today we're going to look at obtuse angles. We spoke about quadrant 1 and quadrant 2 yesterday, this being quadrant 1 and this one being quadrant 2. And we discussed how all primary trig ratios are positive here in quadrant 1 and only sine is positive in quadrant 2. Okay? So we're going to keep those in mind when we go through the questions. Now what we're going to be doing is we're actually going to solve for acute angles. And then we're going to solve for the supplementary. So that's a major word. Supplementary obtuse angles.
Does that mean double?
It means together. So the acute angle, so I'm going to represent that with A, plus the obtuse angle are equal to 180 degrees. Okay? This is an important thing that we're going to have to remember as we go through it. So, in this question, they've given us some angle. We pretty much have absolutely no information except that where it goes on our grid. What we're going to do is we're going to create triangles from there and use our right angle triangles to solve what those angle measurements are. So I'm going to draw a line down to the x-axis here. Okay, so here's our x-axis. And because I can tell what this coordinate is 5 and 4, I can tell you what the lengths of this triangle is. Because this is x and this is y, okay, we'll do y in blue here. The height of this triangle would be how many units? 4 units, since that's how high up y is. The base of this triangle would be 5. Excellent. How can we easily find the hypotenuse of this triangle?
A squared plus squared.
That's right, we can use Pythagorean Theorem. So if I were to say a squared plus b squared equals c squared, and c is always our hypotenuse, we're going to plug 5 squared plus 4 squared is equal to c squared. Remember, the hypotenuse is the longest side, and this arm represents our hypotenuse. Okay? So that's going to be 25 plus 16 is equal to c squared. That's going to be 41 is equal to c squared. Okay? Now to get c by itself, what do I need to do to both sides of that triangle? Square root. Guys ready? So, like Andrew said, we got to square root both sides. When we square root the side with c, the square root and the power of 2 will cancel out. And we're left with the square root of 41, so I'm going to have to put that in our calculator here. 41, what's the square root button?
X squared.
You guys see it? Oh, there it is. 6.4, we'll say. Okay. 6.4. So, in other words, the hypotenuse of this is 6.4. Now what I've done is I'm going to redraw this, just so it doesn't get too confusing on that grid. We now have a triangle where we have all the measurements of every side. Okay? And the angle we were looking for, if you guys remember, was this one I've put in red. So that would be this angle for drawing similar triangles. This is why we had to know our similar triangle rules before. This is 4, this is 5, and this is 6.4. I now know all 3 sides of this triangle, so I can use this information to solve for this angle. I'm going to do all 3 ratios. Okay? So let's say I'm talking about this angle. We're going to call it angle x. Sine x is equal to, what would be considered the opposite side of that angle?
4.
That's right. What would be considered the hypotenuse? That's right. And I forgot to write the x in here. Okay? So that's our sine ratio. If we were to do cos x, what would be adjacent to this angle? 5. What would be the hypotenuse? Still 6.4. I'm just going to move these over so we can fit tan in also. And when we go to set up tan, what does tan stand for? What is the... That's right, it's opposite over adjacent. So what would be our opposite over adjacent?
6.4 with
6.4 won't be involved because that's the hypotenuse. So opposite of it will be 4, and the adjacent will be 5. So I can use any 3 of these ratios, and we'll end up with the exact same acute angle because we knew every side of the triangle here. So what we're going to do now, I actually have to find the angle. Can I just type this into a calculator? Would I just type in sine 4 divided by 6.4? Would that give me the answer? That's right. We have to isolate this x value here. Okay, the x is the angle, so we actually have to move that sine, cos, or tan to the other side. So it will become sine inverse, and then you can probably do this all in one step on your calculator. X is equal to cos inverse 5 over 6.4, and x is equal to tangent inverse 4 over 5. Who can tell me what at least one of them is equal to? Okay, we'll do one of them for you guys. 4 divide 6.4 equals, and then I do sine inverse 38.68. So approximately 37 degrees. Okay? And if you do the other two, what are you guys going to get? Approximately 37 degrees. You will find the exact same angle no matter which of the ratios you set up, because we happen to have all of the information at this time. So we've found the acute angle. Okay? That's the easy part. Let's jump back up to this now. There's a second angle they want us to solve, and this is this larger one over here. But we haven't actually solved any large obtuse angles yet, okay? And we can't with our primary trig ratios. We're only working with acute angles. So what we're going to do is we're going to turn the other side of this into a triangle. So we're going to draw a line down here. Okay? So when we draw this line down, we've now created another right angle triangle. Okay? And what we're going to do is we're going to find the supplementary angle to that obtuse one. So I'm going to color it in purple. We're going to solve this part. Now, there's a fast way. Do I actually have to find every single side of this triangle to figure out this angle? I wouldn't need all three. I really only need two sides. And what's the coordinate here? -7 and 5, right? Well, explain this to me. Can I have a negative distance for a triangle here? No, we can't. Okay? Now this negative, this is where our cos negative, tangent negative, and sine is always positive. If we plug those values in, we'll still get the correct answers, okay? But if we think about this logically, this triangle's length can only really be 7. We don't have -7 in terms of a distance, okay? So this would be 7 down here, and what would the height of it be? 5. So you have a choice when you go to plug things in. I'm going to scroll down, and I'm going to draw that similar triangle again. Yeah, it's all being recorded, all right. The height was 5, like we said, and the base was 7. The coordinate itself was -7 and 5. We're looking for the supplementary angle, so this small acute angle here. Now, if I have the opposite side and the adjacent side, which ratio would I use? Tangent. We're going to use tangent. If I wanted to, I could solve for the hypotenuse and use one of the other two, but we're going to use tangent in this case. Okay? So tangent x, we'll call it again, is equal to opposite, which is 5, divided by 7. X is equal to tan inverse of 5 divided by 7. Okay, I'm going to do this in our calculator here. 5 divided 7 equals, and then, nope, wrong button. 5 divided 7, there it is. Tan inverse, 35.5, we're going to keep it right at that. X is approximately 35.5. But remember, practically we were in the negative range. So what if I had written in x is equal to tangent inverse of 5 over -7? What if I actually use that -7 value? What is my calculator going to give me? 5 divide 7 when it's a negative equals, and then we do the inverse of tan. What did we get? -35. What is tan supposed to be in that range? Tan is supposed to be a negative value, remember? Okay? So because tan is already a negative value, they gave us approximately, sorry.
They want us to put it like on the test equation, like positive or negative.
No, all of our angles, I want to talk about this right now. Can I have negative 35 degrees?
No.
Doesn't make sense. We're not going backwards here, right? So remember, tangent, because we're in the second quadrant, if you were to actually plug in this value of negative 7, it'll give you a negative answer. But it doesn't mean our angle is negative, okay? But we still actually haven't solved for the obtuse one. How do I solve for this obtuse one? Remember, we talked about it being a supplementary angle. So we said that the acute angle, and this would be an acute angle less than 90, plus the obtuse angle is equal to 180. Well, we have the acute angle, right? We know it's going to be 35. So we have 35.5 plus the obtuse angle is equal to 180. But we want to isolate for the obtuse angle. Okay? So when I bring 35.5 to the other side, what is it going to become? It's going to become negative. So we get 180.
Minus 35.
Yeah, minus 35.5. And that means our obtuse angle, which is what we were originally looking for, it's going to be what? 144.5? So that original obtuse, remember obtuse means larger than 90. The obtuse angle was 144.5. Let's pause this.